Greetings. This is presentation or screencast 4 of 5, and in this one we're going to focus on the relationship between soil health and human health, and I think you'll find it pretty interesting and some information that we've already covered, and it'll just tie things together in a nice package that you can take with you. And this slide you've seen before, and it's just looking at the relationship between how pH influences the availability of nutrients. And so we saw before that at pH 6.5, we're saying that's the ideal pH for the availability of nutrients on average. And at low pH, over here, right, we know that the blue nutrients are going to have very high availability for plants, and the green nutrients are going to have low availability. And then if we go over here to the high pH area, we know that the green ones are going to be very available to plants, and the blue ones are not going to be very available to plants. And so where we have low availability of nutrients to plants, that just means that the plant may be deficient in that nutrient, have a difficult time growing. We also know that phosphorus, right, has low availability regardless of the pH. So if we think about, where on earth do we find soils with a pH of 6.5 or near neutral pH? And what do those soils look like? So they look like this, right? So these are our sort of mature temperate region soils. They have loam texture, neutral pH, and on average they have high fertility, right? Thick A horizon, full of nutrients, right? In large scales, if you think about what the soil order is for these, what is it? You can say it out loud if you want, right? It's a mollisol, right? So this is a good example of a mollisol soil. This slide right here shows you where we find mollisols, from a global perspective. And the green areas, right, that I've circled in red there, those are the areas of the world where we have relatively large quantities of mollisols. So in the sort of west and the central portion of the United States, and then in Central Europe, trending towards Eastern Europe. Here is a relationship with those same areas where we find the mollisols from the previous slide, but here we're looking at population density. And the only reason why I'm showing you this slide is just to say that where we have mollisols, we also have pretty high population densities. So the red shaded areas are areas where you have relatively high population densities, up to 500 people per square kilometer, and where you see the green and the grayish areas, those are low population density areas. And so the relationship that I'm going to draw in the next couple slides is where we find mollisols, what does the percent of people living in those areas who are malnourished or undernourished look like? And here's what that relationship looks like. So the same areas where we find mollisols, which are circled in black, are also our green areas on the undernourishment map. And what that means is that in those green areas, we have less than 2.5% of the population that's undernourished. So that means that in those areas, a large percentage of the population is, in pretty good health. And so the relationship that I'm sort of drawing from this then is that there's certainly, something going on between the soil types, that is to say where we have our very high fertility soils like mollisols, and where we have high nutrition of the people, or where we have a very small percentage of the population that's undernourished. If we look at soils that kind of fit this category here, that is to say low pH soils. So think about what a low pH soil looks like, and you can see that the green nutrients, right, which are calcium, magnesium, potassium, nitrate, sulfate, etc., right, these ones, those ones are found or not very available to plant growth, right, at low pH. So what do those soils look like? Those are, classically our highly weathered tropical soils, right? So these ones are, if we classify them or generically categorize them, these are equatorial soils. They're highly leached because of all the rainfall. They're very clayey, they're very acidic, and because they're so leached and acidic, they are low fertility. where do we find soils like this and what do we call them? Those are our oxisols and ultisols, so they're the pink shaded areas and the yellow shaded areas. And where we find them is where we have most of our rain. So that's right along the equator. So you can see the area in South America and the area in Africa, and then in Southeast Asia on the right where we have a lot of ultisols. So these are low pH, low fertility soils. So the next slides are going to look at the same relationships that we looked at previously with the mollisols, but this time we're going to look at these areas for oxisols and ultisols and see what it looks like. So here, again, population density, and the point here is just showing you that in some of these areas there's very high population densities, in other areas there's not, and we want to see, how these areas and the soil types in those areas relate to the nourishment or undernourishment of the populations that are there. But there's one other feature that's kind of interesting to look at, and that feature is kind of unique to our highly weathered soils or our oxisols and ultisols, is the ability of these soils to retain phosphorus. So oxisols and ultisols have an extremely high ability to retain phosphorus, and the reason why that is important is because phosphorus, of course, is a plant essential nutrient. It's required in high quantities for plants, and of course it's also going to be required by the organisms, people, and animals that are consuming those plants. So I should have said this before, but where you see the red areas, right, the red shaded areas are the areas that have a very high phosphorus retention potential, and the greenish areas and the yellow areas have a low to moderate phosphorus retention capacity or potential. This is the same relationship that we looked at before, but in this case we're looking at the percent of the populations in the areas where we have our highly leached, low fertility soils like sub-Saharan Africa, South America, and Southeast Asia, the percent of the population that's undernourished. Where you see the red and orange colors, those are areas where you have 20 to 35% or more of the population that's undernourished. And of course, right, comparing that to areas where you have mollisols, like in America or in Central Europe and Eastern Europe, and then of course Western Europe as well. Those are areas of the world where we said we had our mollisols. That's where we have less than 2.5% of the population that's undernourished. So again, the idea here is that there is a correlation between soil types and the percent of the population that's undernourished, and certainly, right, the percent of the population that's undernourished has a correlation to the development of those societies or those areas of the world. So where you have your highly leached soils, your oxisols and ultisols, that's where you have a very high percentage of the population that must be involved in direct crop production, agricultural production. Upwards of 50% of several countries in Africa of the populations there are directly involved in food production, compared to in America where we have, what is it? It's less than 2% of our population is directly involved in food production. And so what that relates to then is the amount of people that are available to do other things besides produce food. In our low fertility soil areas of the world, you have 50%, maybe less, maybe slightly more than that are available to do other things than produce food. And in America, we got upwards of 98% of our population that can be involved in doing other things besides food production. What are those things? Right, those things are developing infrastructure. Right, they're developing the intellectual capital of those areas. They're becoming doctors and lawyers and designing new things, right, new products. And so what that leads to then is to the development of a society. And in the areas where we got our low fertility soils, high percentage of the population is directly involved in producing food, there's a much lower percent of people that can be involved in those things. And so those areas of the world then are stymied in terms of potential development. And so that's led to a big disparity in the world between the resource allocation, and also how our soils have developed, or how our societies have developed. And I would say, right, the point that I'm making in this discussion here is that certainly there's a relationship to our soil types. And now, right, you know and you understand why that is. Awesome stuff.